So now we're going to start looking at entire implicit formulas, like the one I've written on the page over here. And we want to find the derivative, a formula that gives us the slope of that implicit formula. For our first example, and I have 3 examples we're going to take a look at in this video. For our first example, I want to find the formula for dy dx of the implicit formula y cubed plus y squared minus 5y minus x squared equals -4. Because I feel like these implicit formulas are kind of very different than the things you're used to working with, before we do this, I'd like you to go to the website desmos.com, Edpuzzle will give you the link to that there. I would like you to type in this implicit formula and see what the graph of it looks like, because it's still something that we can find the slope of in various places. Take a moment and go graph that thing. So now that you've graphed it and have seen that, yes, we should be able to find the slope of a line tangent to it in various places, we need to go find our derivative. Here is our procedure for dealing with something like this. First thing I need to do is differentiate both sides with respect to x. I'm going to go find d dx of both sides. Differentiate both sides with respect to x, which just means that x is our independent variable and y is our dependent variable. Step number 1, we're going to differentiate both sides with respect to x. Step 2, leave that for now. We'll deal with that in a moment. First thing I want to do is find the derivative of both sides. I'm going to go and write down d dx. Let's find the derivative of y cubed plus y squared minus 5y minus x squared. And I want to find the derivative of -4, just like the problems that you looked at in the first video from this section. Okay, so I'm going to go do my derivative now. The first one, the derivative of y cubed is going to be 3y squared times, what do we have to multiply by because we're doing the derivative of something with a y in it? Hopefully you said dy dx. 3y squared dy dx. Next one, the derivative of y squared is going to be 2y times what? I hope you said dy dx. Next, the derivative of minus 5y is minus 5 times, well, the derivative of y. What's the derivative of y? I hope you still said dy dx minus, well, now the derivative of x squared, there's no y in here. This is just our normal derivative rule stuff. So we're going to say the derivative of x squared is just 2x. Next, moving to the other side. What is the derivative, with respect to x, of -4? -4 is just a constant, so I hope you said 0. I'm done with the calculus part of this. Step number 2. My goal was to create a formula for dy dx, a formula that would help me find the slope anywhere. Well, I've got those dy dx symbols, but I need a formula that reads dy dx equals by the time I'm done. So I now need to go through some algebra to solve this thing for dy dx. I need to go through some algebra to solve this thing for dy dx. To make this happen, I need to get the terms that have a dy dx on them, with them, on one side, and the terms without on the other. How about I take this minus 2x and just add that to both sides? Which is going to give me 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. The reason I did that is because now each term here has a dy dx in it, and I can go and factor out the dy dx. I'm going to say that dy dx times, in parentheses, 3y squared plus 2y minus 5 equals 2x. And then to finish off this problem, I'm just going to divide by this thing, giving me a formula for dy dx. dy dx equals 2x over 3y squared plus 2y minus 5. And that's my answer. I'm going to make the video pause for a moment so you can take a moment and make sure you get all that copied down. Again, the whole point of what we did is we created a formula to find the slope of that original function, or that original implicit function. The different thing between this and what we did in the last unit is if I want to find the slope somewhere, I can't just use an x value, because we saw when we looked at the graph, one x value might have multiple y values. I need to use both an x and a y value. More with this a little bit later when we actually find some tangent lines. Let's take a look at another example. I told you there'd be 3 examples in this video. Let's take a look at this problem. I want to find dy dx given the implicit formula x cubed y minus 2xy minus 3x squared y squared equals x plus y. I would like you to copy that down, and when you're done, head over to Desmos, graph it, and let's see what this thing looks like. Well, now that you've hopefully seen it, we're going to go and we're going to create our dy dx formula. I'm going to go and find the derivative of both sides. I want to find the derivative of x cubed y minus 2xy minus 3x squared y squared. And I want to find the derivative of x plus y. Now, to find the derivative of x cubed y, what rule am I going to have to use? Hopefully you said product rule. This is the product of x cubed times y. So I'm going to go do this. First is x cubed times the derivative of the second. Well, derivative of y, dy dx. Plus second, y, times the derivative of the first, 3x squared. And that's my derivative of x cubed times y. First times the derivative of the second, plus second times the derivative of the first. For this next piece, I'm going to say minus 2 times, I'm going to treat the 2 as a constant and leave that up front. And I'm going to go do my product rule on x times y. You know what? How about you see if you can go do the product rule on x times y. You go do your first times derivative of the second plus second times derivative of the first. First is x. Derivative of the second is dy dx plus second, y, times derivative of the first, times 1. Next, minus 3 times, again, I'm going to treat that as a product with a 3 constant out front. How about you see if you can go use the product rule on x squared times y squared? Take a moment, see if you can do that. First, x squared times derivative of the second. Derivative of y squared is 2y dy dx plus second y squared times derivative of the first is 2x. On the other side, the derivative of x plus y, well, the derivative of x is 1, and the derivative of y, dy dx. The next thing we need to do is a whole lot of distributing on the left side. Take a moment and go do some distributing. We're going to get x cubed dy dx plus 3x squared y minus 2x dy dx minus 2y minus 6x squared y dy dx minus 6xy squared equals 1 plus dy dx. We now need to get the dy dx's on one side and the terms without a dy dx on the other side. I don't really see one way that's easier than another way to do this one. We can either put the dy dx's on the left, or we can put the dy dx's on the right. How about you go take a moment, do one of those options. I'm going to try to do the work for both of those, because we should get the same answer by the time we're done. So take a moment, move things around, and I'll make the video pause. If I want my dy dx's on the left, dy dx on the left, let's see, I'm going to get x cubed dy dx minus 2x dy dx minus 6x squared y dy dx minus, I'm going to bring that to the other side, dy dx. If you feel like you need to show the algebra in the middle, absolutely go do that. On the other side, I have a 1. This piece is going to the right, so minus 3x squared y. This piece is going to the right, so plus 2y. This piece is going to the right, so plus 6x y squared. If instead you chose to put the dy dx on the right, let's see, we're going to get 3x squared y minus 2y minus 6xy squared minus 1 equals dy dx minus x cubed dy dx plus 2x dy dx plus 6x squared y dy dx. You should have either this or this. I'm now going to go factor out my dy dx's in both of these versions. If you put dy dx on the left, you're getting dy dx times x cubed minus 2x minus 6x squared y minus 1 equals 1 minus 3x squared y plus 2y plus 6xy squared. I might as well just go finish this and get my formula. Dy dx equals 1 minus 3x squared y plus 2y plus 6xy squared over x cubed minus 2x minus 6x squared y minus 1. And that's my formula for the derivative. If instead you put dy dx on the other side, I'm going to keep going through the work, but we should be getting the same final answer by the time we're done. I'm going to go factor out, and I've got 3x squared y minus 2y minus 6xy squared minus 1 equals, I'm going to take out dy dx and get 1 minus x cubed plus 2x plus 6x squared y. I'm going to divide, and I'm going to get dy dx equals 3x squared y minus 2y minus 6xy squared minus 1 over 1 minus x cubed plus 2x plus 6x squared y, which should be the same thing as what I have over here. And, oh, wait a minute. Let's see, I've got 3x squared y, but here I've got negative 3x squared y. I've got negative 2y. It actually looks like all of my signs are the opposite. Well, here's the deal. These two things actually are the same thing, because if you factor a negative 1 out of the top and factor a negative 1 out of the bottom, you'll get exactly the same thing over there. And then negative 1 over negative 1, they're going to cancel. It's not going to matter to me if your answer looks like this or if your answer looks like this. They will be the same thing. The only time it's going to matter which way you write it is if you're given a multiple choice question and maybe this is your answer, but this is what shows up. What you need to think is, if your answer is not showing up, could you factor a negative 1 out of your top and out of your bottom to make it into one of the answers that shows up? So I did want you to see that you'll get different looking answers based on what side you put your dy dx on, but they actually mean the same thing. One more example. We are going to find dy dx for the cosine of x plus y equals 1/2. And I would like you to copy that down, but do not go to Desmos yet. Just copy that down. Now, I'm going to go and find my derivative. I want to do the derivative of the cosine of x plus y, and I want to do the derivative of 1/2. Well, to do the derivative of the cosine of x plus y, what rule am I going to have to use? I hope you thought chain rule. Derivative of cosine is negative sine, so I'm going to get the negative sine of x plus y times, okay, I now need to multiply by the derivative of the thing inside. Well, the derivative of x is 1, and the derivative of of y is dy dx. On the other side of this, the derivative of 1/2, just 0. To move on, I'm going to go and I'm going to distribute this piece to both of the things inside the parentheses. I'm going to get negative sine x plus y minus, I'll move my dy dx out front, I'm going to say dy dx times the sine of x plus y equals 0. You take a moment, go make the dy dx piece go to one side and solve for dy dx. I've got negative sine x plus y equals dy dx times the sine of x plus y. I'm going to divide both sides by the sine of x plus y. I'll just switch sides over here and say dy dx equals negative sine x plus y over sine x plus y. That's kind of interesting and kind of weird. I'm getting negative 1 for my slope, which means the slope should be negative 1 everywhere. But I know the only thing that has a slope of negative 1 everywhere is just like a slanted line, so this is kind of weird. Take a moment, go to Desmos, and let's see if our answer actually does make some sense. Hopefully you saw that even though the graph looked kind of crazy, it truly was just made up of pieces that had a slope of negative 1 everywhere. In the next couple videos, we're going to talk about tangent lines, we're going to talk about horizontal and vertical tangents, and we're going to talk about second derivatives.